Alright, today we're looking at being able to combine like terms to simplify an expression. So, the first things first, what makes a like term, or how do we know when we have like terms? A term, first off, is something in an expression that is separated by addition or subtraction. Okay, if it's multiplication and division, then those are individual factors of that term. But, so like in this expression, there'd be three terms. That's a term, that's a term, that's a term. Okay, so it doesn't matter how many variables there are or anything like that. As long as there's an addition or subtraction sign in between, it's a new term. Okay, so what makes a like term is when we have the same variables with the same exponents on those variables. Now, the number or the coefficient, okay, so like these numbers that are here, 3, 4, and 3/4, those don't matter as far as like terms go. Only the variable portion matters, so the x's and the y's. Now, just because they have the same variables and the same exponents, remember they have to actually be on the right variable too. So like 3x squared y and 4xy squared, they both have an x and a y. They both have an exponent of 1 on one of the variables and 2 on the other, but it's not the right way around. Like those two would not be like terms. It would actually have to be another term with x squared y in it for them to be like terms. Okay, so we're going to look at how to combine them and why we're allowed to combine them. The y is actually really easy to understand given yesterday's lesson. So we'll take a relatively simple example. We'll just take 5x plus 4x. I'm sure most of you know last year that we were able to combine these into 9x. But why are we able to do that? Order of operations says we have to multiply 5 and x and 4 and x first. But if we remember factoring out common factors from last time, if we factor out our GCF of x, we can rewrite that expression as x times 5 plus 4. And we said that was okay to do. So since that's okay to do, now that we have 5 plus 4 in parentheses, we can make that into a 9. So it's x times 9, which is the same thing as 9x. Now, do you have to write this? Absolutely not. You just need to understand that they're like terms and be able to add them. But I think it's nice to understand that because now, if you're confused on whether or not you can add two terms, you can just think, well, could I pull out a common factor and have nothing but numbers in the parentheses that I could then add together? If you can't, they're not like terms. Okay. So we'll work on doing some combining like terms. The biggest thing you have to watch out for when combining like terms is negatives and subtraction. Okay? So the one thing that I would suggest that you do is I would change any subtraction to addition of the opposite, or at least think about it that way, and I think you'll be okay then. Since you guys did this last year, I'm going to let you go ahead and try A, B, and C on your own. Pause and then come back. I'm assuming you're back and ready to go. Here we just get 14x. They are like terms. We could put them together. Here, just the 3x and the negative 4x. Remember, because we can change that to plus negative 4x are like terms. So 3 and negative 4 is negative 1. So we get negative x plus 2, or negative 1x plus 2, or 2 minus x, or 2 plus negative x. All those would be good. In the bottom one here, C, we've got a negative 6c and a negative 7c. When we add those together, we get negative 13c plus 13. Or the other way around, 13 minus 13c would be great too. So, I'm assuming that was probably a review for most of you, which is great. We can do it with the distributive property too. Again, you know the distributive property, you know combining like terms. I'm going to show A, and then you guys are going to show me the rest. So up here, distribute. Again, how much work you show is entirely up to you. So I'm distributing a positive 5. 5 times 2x is 10x, plus 5 times 4 is 20. Here, be careful, I'm distributing a negative 3x. Okay, that's really important that we remember that. So negative 3x times 2x is negative 6x squared. Negative 3x times, this is a negative 1, so I've got two negatives, so that's going to be a positive 3x. Look for your like terms, okay? You don't have to actually move them next to each other, but look, there's my like terms. Those are the only ones that have the same variable and the same exponents. 10 and 3 make 13, so we get 13x plus 20 minus 6x squared. And you could put those in any order that you want. Typically, I think you'd actually start negative 6x squared plus 13x plus 20, but, you know, that order is just fine too. So try B and C on your own, pause, and then come back. Welcome back. Here, we should get 7 minus 2x minus 5. It's like we're distributing a negative 1 when there's just a subtraction sign out in front of parentheses. And we're combining 7 and negative 5 to get 2. We're left with 2 minus 2x. This bottom one is honestly just more obnoxious than anything else, but it's really not terribly complicated. So you're distributing a 4 here, and you're distributing a negative 5 here. So just multiply your coefficients by 4 in the first one. You don't have to worry about signs at all. They are staying exactly the same. Now you're distributing a negative 5 into the second set of parentheses, so those signs are going to switch around. We get minus 30x, minus 25y, and we're doing negative 5 times negative 1 at the end, so that becomes a plus 5. Looking for my like terms. Those two are like terms, and they make negative 2x. Negative 8y and the negative 25y are like terms. They make negative 33y. And the two remaining numbers of positive 12 and positive 5 are like terms, and they make plus 17. That's really it. You don't really need to learn a whole lot new here. It's just kind of combining that more complicated distributive property with combining like terms. Big thing to make sure of is that you're only combining terms that have the same variable, same exponent, and that you're very careful with your negative signs when you're distributing and when you're combining like terms. That's it for today.